Okay, welcome back, pre-calc students. We are now going to go back to those functions and we're going to finish up a little bit. So we have a baseball. It is hit at a point 3 feet above the ground at a velocity of 100 feet per second. It is hit at an angle of 45 degrees, and the path of the baseball is given by the function the height of the baseball at any point in time is equal to negative 0.0032 x squared plus x plus 3, where x is how far away the baseball is from home plate. So that will allow me to figure out how high is the ball at 10 feet, how high is the ball at 20 feet, how high is the ball at 50 feet. And what we want to know is, will the baseball clear a 10-foot fence located 300 feet from the plate? So I have two values. I have the 10-foot fence and I have 300 feet from home plate. And so I want to ask, what would I plug in? Do I plug in the 300 or do I plug in the 10? And since my x value is a logical place to plug in, since my x value is how far away the ball is from home plate, I'd want to plug in the 300. So I'm going to figure out, what is the height of my ball 300 feet from home plate. I'm going to do that by negative 0.0032 times 300 squared plus 300 plus 3. And I'm going to go ahead and just plug it into my calculator like that. So let me grab this calculator, maybe, sorta, kinda. I'm not seeing it anywhere. Where are you? Oh, it looks like it's way up here. Why is it up there? There we go. Okay. So I'm going to exit out of this graph here. And I'm going to go ahead and do negative 0.0032 parentheses 300 parentheses squared plus 300 plus 3. So I'm just typing it in the way it is. Let's see what we get. Looks like we get 15. And then remember, this is the height of my ball, so 15 feet high. So now I'm going to go back and read my question. Will the baseball clear a 10-foot fence located 300 feet from home plate? Well, it looks like at 300 feet my ball is going to be 15 feet high. So now I'm going to answer the question. Yes, the ball will clear the fence excuse me, by 5 feet. So we'll have an extra 5 feet above the fence. And that's it. And so a lot of times I get questions from students, especially in pre-calc, well, why did you explain that? And that's because in AP Statistics and AP Calculus, when you get a word problem like this, and we don't really we call it word problems, but really it's a contextual problem. We have a context, there's a situation here. Explain what this means in terms of the situation. And yes, the ball will clear the 10-foot fence, and it's going to clear it by 5 feet because it's actually at 15 feet high. So any way that you explain it based on the situation will give you the points you need for that problem. And that's what we're really looking for. And the more we practice it, the better we get at it. Okay, so now what we're going to do is we're going to do the difference quotient, which is really us practicing using function notation. And we're going to practice using it all year long for this. And it's setting us up to learn how to do calculus. And so when we do calculus, we start doing limits. That helps us find the derivative of an equation or a function. And that's what we're going to do. We're going to find the derivative. We're going to help work with that. And so the way we do this is we do two different types of function inputs. So we take our original function, we're going to plug in x plus h. Then we're going to subtract the original function, and we're going to divide everything by h. So this is how it's going to look like. I'm going to take my original function, and I'm going to plug in x plus h. So I take this, and where there's an x, I'm going to plug in x plus h. So there's my original function with, instead of x, we have x plus h. Now I'm going to take and I'm going to subtract the original f of x. Then I'm going to go ahead and divide by h. So now what I have to do is I have to simplify this. So the very first thing I'm going to do is I'm going to go ahead and distribute. So I'm going to distribute this in, distribute that in. So now it looks like a negative 2x, a negative 2h, plus 4. Then I'm going to go to the green one, and remember I'm subtracting the original. So that means I'm going to distribute this negative inside. So negative times negative is positive. Negative times 4 is negative 4. And now the whole thing's just going to be over h. And then the thing I like about this is, even though it seems tedious and weird, is we get stuff canceling out. Because now look, negative 2x, 2x. 4, negative 4. If you find that you don't have things canceling out, you've done something wrong. So now all I'm left with is this negative 2h over h. And what do I find now? The h's cancel to give me the answer of negative 2. And so it seems tedious and weird, but it works out really nicely. So now we're going to do the same sort of thing with a more complicated problem. And these are the ones where people really struggle. So we're going to take the original, and wherever there's an x, we're going to put in this x plus h. So instead of x, we put in x plus h. Instead of x, I'm going to put x plus h. Now I'm going to go ahead and I'm going to subtract that original function. So I'm going to subtract the x squared minus 4x plus 7. And the whole thing will be over h. So now what I'm going to go ahead and do is I'm going to do that x plus h squared. So this kind of goes back to what we talked about before. We can't distribute that exponent. This is really x plus h times x plus h. And when we FOIL that out, we're going to get x squared, xh, hx, which is really just xh, hh. So this multiplied out really becomes x squared, there's 2 xh's, and an h squared. Now I still have to, that was only this part right here. I still have to do this. Distribute that negative 4. So now I have a negative 4x, and a negative 4h, and a positive 7. So you can start seeing where this gets pretty tedious. But remember, we're going to get lots of stuff canceling out, so we just have to get there. Let me move this up. So now I'm going to distribute this negative inside. So I get negative x squared, and I get negative 4x, and I get negative 4x, no, it's positive because I have to change that sign, negative 7. And then the whole thing is over h. Now remember, now that I have that simplified out, I'm looking for things that are cancel, and they're going to cancel. X squared, negative x squared. Negative 4x, positive 4x. Positive 7, negative 7. Okay, so now I have a little bit more than last time. I have a 2xh, I have an h squared, I have a negative 4h. If you ever have anything left behind that doesn't have an h, you've probably done something wrong, because all of these need to be divided by h. This gets divided by h, this gets divided by h, this gets divided by h. So we should get some h's canceling. And here, this h cancels out with one of these. So technically, my answer is 2x plus h minus 4. And again, this is all foreshadowing to using function notation to help us calculate the derivative of a function, which we will find out later on all the different implications that has. So your assignment, And again, if you have questions, come to class, let me know what you have questions on. And it's great working with you. I can't wait to see you in class next.